Hey everyone, so welcome to our part 3. We're going to run through a couple more examples, so I would encourage that you pause the video along the way, try them out, and then come back either if you get stuck or you're looking for a verification for something just to see if you're on the right track, and we'll just kind of go from there. So we'll start off, and I'll pause the video, give it a try, and come back when you're ready. Alright, so for our first one, I've got two terms on the bottom, and so I can see kind of right away that I'm going to have non-permissible values here where x can't be, it looks like it can't be 3, it looks like it can't be negative 3, so plus or minus 3. Now, same thing that we did from before, I'm going to cancel out these denominators by multiplying them on each term on the top. So multiply by x minus 3 on the top on each thing. So x minus 3 and x minus 3. So in this case, now I can see my x minus 3's cancel out, which would be kind of the purpose for doing that step, and then I'll have a 3x left over here, plus 2 times x minus 3 equals a 3x minus 1 and an x minus 3, all over x plus 3. So that helped me simplify that step just a little bit. So my next thing that I'm going to do is I'm going to take this bottom part and do the same thing. So each term, remember, gets multiplied by x plus 3. So times by x plus 3, times by x plus 3, and times by x plus 3, or multiplied by that denominator value. X plus 3 divided by x plus 3, that's 1. Again, purpose for kind of doing that step. And then what I'm left with at the end is 3x and x plus 3 plus, and then a 2 x minus 3 x plus 3 equals, and then a 3x minus 1 and an x minus 3. So notice now I have no more denominators, and really you could probably compare the top parts here to what these ended up being, and could probably figure out how to get there in one step, really. I break mine apart into just multiple steps, taking it one at a time just so you can see, but certainly if you can see the multiple steps, then feel free to kind of approach the problem that way as well. So our next thing is that I'm going to expand these brackets. So let's start off and do the first one. Looks like a 3x times an x is a 3x squared. 3x times 3 gives me 9x. Now this one has two terms in it, so I'm just going to start with my 2, and I'm going to open up a bracket, and we're going to FOIL this out. X squared, and then would be my first term, x times x. My outside term would be plus 3x. My inside term would be minus 3x, so right away I can actually see that these cancel each other out, and negative 3 times 3 gives me negative 9. Same thing here, I have to FOIL this out. 3x times x is 3x squared. 3x times minus 3 is minus 9x. Minus 1 times x is minus another x. Minus 1 times 3 is plus 3. So simplifying this out now, 3x squared plus 9x. This is only going to be x squared minus 9, so I have plus 2x squared. 2 times negative 9 is negative 18 equals, and then I'll have 3x squared, and then minus 9x minus another one is minus 10x plus 3. Now I'm going to start to combine my like terms together. 3x squared plus 2x squared looks like 5x squared plus 9x minus 18 is equal to 3x squared minus 10x plus 3. Because I have squared terms, linear terms with the x's, and then constants, I need to combine everything together. So I'm going to be subtracting a 3x squared, I'm going to add a 10x, and I'm going to subtract a 3. So subtract a 3x squared, add a 10x, minus a 3. That cancels all three of these out. And on this side, it looks like now I have 2x squared, right? 5x squared minus 3x squared, 9x plus 10x looks like 19x. And minus 8 minus 3 more is minus 21. So 2x squared plus 19x minus 21 is equal to 0. This sets up a hard trinomial, so two things that multiply to give you negative 42, and those same two things will add together to make 19. So again, looking for two things that can multiply to make negative 42 and add to make 19. So I start going through my multiples. Because the number is so far apart for the adding, I know that the numbers must be relatively far apart, so even if I started with 2, I'd have 2 times 21, and I can see that 2 and 21 actually will work. Because this is a minus, that means that one of these is going to be positive and one's going to be negative. So it looks like the 21 is going to have to be my positive value, and the 2 is going to need to be my negative value. And that's because I have a plus 19 here. So plus 21 and minus 2. So then I have 2x squared. I'm going to write the 2 first here just because I can see that it factors easy. And plus 21x minus 21 equals 0. And then I can see I have some pretty common factors that are here. 2x, x minus 1, plus 21, x minus 1 equals 0. The common factor here is x minus 1, so it looks like I have an x minus 1, and I have a 2x plus 21 equals 0. That means I have x equaling 1, and in this side it looks like 2x plus 21 has to equal 0. So that means that 2x is equal to negative 21, or x is equal to negative 21 over 2. So I have two separate solutions that are here that I'm going to have to check because there's no condition here. In a previous video we talked about extraneous roots. Well, those extraneous roots don't really apply here to this scenario. So we're going to have to go through and check these answers to make sure that they match up. So I'm going to go and erase the top part here, just so we can see kind of what we started with, and really see how we can check these over to see if we end up with our correct value at the end. Okay, so let's go through and check these out. So as a check, I've got, start with my x is equal to 1 first. So 3 times 1 over 1 minus 3 plus 2, does that equal 3 times 1 minus 1 over 1 plus 3? Right? Everywhere there's an x, I just plugged in a 1. So 3 times 1 is 3, 1 minus 3 is negative 2, plus 2, does that equal 3 times 1 plus 3 minus 1 is 2, and 1 plus 3 is 4. So 3 over 2 and plus 2 more. If I wanted to make an equivalent fraction here, this 2 is really over 1, which means that I can make an equivalent fraction and call this 4 over 2. So really, this is saying negative 3 over 2 plus 4 over 2, does that equal 2 over 4? Really, 2 over 4 here, I can see right away, 2 is going to reduce down to 1/2. So 4 minus 3 is 1. Combine with a like denominator, 1/2 equals 1/2, and I can see that 1 works. So what about my other one? Negative 21 over 2. So this one's going to be a little bit more interesting to try to check and solve for. So negative 21 over 2, 3 times negative 21 over 2 over top of 21 over 2 minus 3 plus 2, does that equal 3 times 21 over 2 minus 1 over top of 21 over 2 plus 3. There's a lot going on here. So 3 times minus 21 is minus 63. Okay, minus 63 over 2. over top of 21 over 2 minus 3. So really, remember, this is really over 1. I can create an equivalent expression and call this 6 over 2. So 21 minus 6 is 15 over 2 as an equivalent expression. Plus 2 equals, same thing here, 63 over 2 minus 2 over 2. And just kind of set up that equivalent expression, right? 1 over 1 is the same as 2 over 2. All over top of 21 over 2 plus, and then this is going to be 6 over 2. So now think of this like a division. 63 over 2 divided by 15 over 2. What do you do when you divide fractions? You flip the second term and multiply. So hopefully you can kind of see that the 2's, and write this out on paper if you're not sure, the 2's are going to cancel, and I'm going to be left with minus 63 over 15. And again, I encourage you to write this out with a division symbol and actually flip it and multiply them out. Okay, and just see if you get to this point. So this is now minus 63, and this is over plus 2. I'm going to make this an equivalent expression at this point and turn this out of 15. So this is really 30 out of 15, right? 30 divided by 15 is 2. 63 over 2 minus 2 over 2 is 61 over 2. And 21 plus 6 is 27 over 2. Same things happen here with the 2's, and I have 61 and 27 left over. So let's see what we get here. 63 minus 30 looks like it gives me minus 33. So 63 minus 30 is minus 33 over 15. Does that equal 61 over 27? And so in this case, this one is a negative, and this one is a positive. So I can see that these are not going to be the same value. So it looks like in this case that negative 21 over 2 doesn't work and doesn't give me a value that's going to check out to be the same thing. So in this case, this doesn't work, which means that I have only one solution at x is equal to 1. Okay, so let's take a look at number 5 and see if we can figure that one out. And then we'll move on from there into some word problems. So again, try this question out, see how you do, and come back when you're ready to check over the answer for it. Alright, so solve and find the non-permissible values, and it gives us a set of different equations to work with here. So we're going to approach this the same way that we approach the other ones. We're going to start to factor first and see what can factor out. So in my first term, I really can't do anything with this 4k plus 1 or the k plus 2, the k plus 1, the k minus 2. And then this, are there two things I can think of, like a multiply to make 24 and add to make negative 4? So if I start to list my values, I'd have 1 and 24, I'd have 2 and 12, 3 and 8, and 4 and 6. Okay, all those multiply to make 24, but none of them have a difference anywhere in there of 4. So this thing has solutions, they're just not whole numbers, which means that I'm not going to worry about factoring it right away. And in fact, we're just going to leave it the way that it is, and then we're going to come back and combine our like terms later on. So let's take a look and see what else we can do here. The last thing here is k squared minus 4. This is a difference of squares type problem, so that's k plus 2 and k minus 2. So in this case, now I can see, okay, I've got k plus 2, a k minus 2, k plus 2, k minus 2. So I need to get rid of these. So I'm going to do the same thing I did before. I'm going to start, I'm going to multiply by a k plus 2, multiply by a k plus 2, and then multiply this whole thing here by k plus 2. That's going to help me cancel out the k plus 2's. And over here, k plus 2 is also going to cancel itself out as a whole term. So what do I have left? I have 4k minus 1. That's that whole term. That's all that's left over. Minus, so I'm going to tuck this in brackets, minus k plus 1 and a k plus 2 over top of k minus 2. That's going to equal k squared minus 4k minus 24 all over k minus 2. So now I'm going to do that second part, and I'm going to multiply this by the other denominator, which is k minus 2. So multiply by k minus 2, multiply by k minus 2, multiply the other term by k minus 2. These cancel, and I can see that the k minus 2's cancel here and here. So now I have no more denominators left. So now I can just write what I have left over and start to solve that. So I have a 4k minus 1 and a k minus 2 minus a k plus 1 and a k plus 2 equals, and then this one is actually already expanded for me because I couldn't figure out a way to factor it cleanly, and so we just left it as it was. Now I've got two binomial terms that need to be multiplied out and combined together. And so here I've got 4k squared minus 8k, so 4k times 2, so minus 8k, minus 1 times k is minus k, and minus 1 times minus 2 is plus 2. Minus, I'm going to expand this bracket out first and then multiply the negative through. So k squared plus 2k plus 1k plus 2, right? First, and then outside terms 2k, inside terms k, last term 2. And then k squared minus 4k minus 24. Now I'm going to combine where I can. So 4k squared minus 9k plus 2 minus, notice here I'm going to have 3k in the middle here, so minus k squared minus 3k, right? The negative is going to multiply in, and then at the very end here, a negative times a positive 2 give me a negative 2 equals k squared minus 4k minus 24. Now I've got 4k minus k squared, so that's 3k squared. Sorry, 4k squared minus 3k minus a k squared is 3k squared. Minus 9k minus 3k looks like minus 12k. And 2 minus 2 is actually 0, so they just cancel each other out altogether. That equals k squared minus 4k minus 24. So let's start to combine our like terms together. I'm going to minus a k squared, I'm going to add a 4k, I'm going to add a 24. And so that helps me cancel all three terms here, as long as I do it on this side as well. So minus k squared plus a 4k plus a 24. So 3k squared minus k squared is 2k squared minus 8k plus 24. And that equals 0. So all these terms cancel out. Now I'm left with something that I can look like I can start to factor. But the first thing I should do when I factor is to take a look at these common terms. So it looks like I can take a 2 out to start off with. K squared minus 4k plus 12. That makes this a lot easier to manage and to see. So I've got a 2. Now I've got two brackets. I'm looking for two things that multiply to make 12. And those same two things add to make negative 4. So it looks like negative 6. So k minus 6. And k plus 2 looks like it'll do the trick. Right, negative 6 times 2 And somewhere over here, sorry, I missed a negative sign right there. So this guy shouldn't have been a positive, he should have been a negative. So we're just going to go back and fix that. Okay. Oh, and I see what I did here. I just wrote out the wrong symbol. So I wrote k squared minus 4k minus 24 should have been plus 24. So we'll just make a little correction, and maybe you picked up on that already. So plus 24 all the way through, which means here I'm going to have to minus 24, minus 24, minus 24, minus 12. So just had a little mistake up there where I just wrote down the wrong sign, and you can see kind of how it affected everything all the way through. But now in this case I've got this correct now. So two things that multiplied, sorry, to make negative 12, and added to make negative 4. So negative 6 plus 2 is negative 4, negative 6 times 2 is negative 12. So now in this case I can see that k is equal to 6, and I can see that k is equal to negative 2. So I have two potential answers for k here. But I haven't talked yet about this non-permissible value part. So if we were to go back and we were to look at the very beginning here and what k can and can't be, k actually can't be negative 2 and positive 2. So k can't be plus or minus 2. That means that this solution is actually a non-permissible value. Okay, non-permissible value. So this can't be a solution, which means that x is equal to 6 is my only potential solution. So let's check and see if x is equal to 6 is in fact a solution to this question. So here, as a check, we have 4 times 6 minus 1 over top of 6 plus 2 minus 6 plus 1 over 6 minus 2 is equal to, and then here I've got quite a bit going on here. I've got 6 squared minus 4 times 6 plus 24. All over 6 squared minus 4. So let's start to simplify this. 4 times 6 is 24. 24 minus 1 is 23. 6 plus 2 is 8. Minus 6 plus 1 is 7. 6 minus 2 is 4. Equals 6 squared is 36. Minus 24. Plus 24. All over 6 squared is 36. Minus 4 is 32. The 24s will cancel. Plus and minus. So 23 over 8. Minus, I'm going to double this, 14 over 8 to create an equivalent fraction, is equal to 36 over 32. So is this a true statement? 23 minus 14, looks like that gives me 9 over 8. 23 minus 14 is 9, common denominator is 8. And it looks like 36 and 32, if I divide each one of them by 4, looks like I'm going to also get 9 over 8. So that checks out. So k is equal to 6 is my right answer for this one. K is equal to negative 2 is a non-permissible value for this question. So k is equal to 6, also with the idea that k is not equal to plus or minus 2 as a value, as a non-permissible value. So those two questions obviously take a little bit of time to go through. I would encourage at this point then that if you have any questions, let me know, and I'll pause the video here and we'll pick it up in the next part.